All right. Hey, this says 20 minutes. It said 25 minutes. I said 25 minutes. Where did they go? Oh, wait, never mind. Hey, folks. So my talk is called Build Your Next Website in Swift because for over 30 years now, HTML has been a fantastic way for describing the structure of web pages. And what that means is we can write HTML like this. This thing has a heading. We have a paragraph of text. We have some emphasis inside the text. And a link to another page. But what happens if I forget this closing EM? Without it, browsers assume everything that follows should also be emphasized. And that's not what I wanted. But it's easy to do because HTML is just text. So, even though if you write perfect HTML, there are other, bigger problems. First, how can you make sure your pages look the same on all browsers? How can you make your page adapt to different screen sizes, such as iPhone and iPad? How can you use more advanced UI elements, such as drop-down menus, carousels, and accordions? And most importantly, how can you be sure your site is accessible to everyone? Now, all four of these really boil down to one big problem. Most people don't have enough time to become experts in Swift and also experts in HTML. So, I think the solution is not to use HTML, or at least not directly. Instead, I want to propose we use Swift to build our websites. And back in 2019, when Apple announced Swift UI, there was the usual What's New in Swift presentation. During that talk, they showed this HTML. And they also showed what it looked like in Swift. Except, of course, they put the HTML into a string. This code is objectively worse because we now can't use HTML editors to get autocomplete or syntax highlighting. But then they showed this. This sample was then a new feature called result builders that define the structure of web pages in pure Swift and use that to generate HTML. And now the compiler can check our code is good, which means it's impossible to miss an ending tag by accident. Doing so will trigger an error. Now I want to look at how we can build this for real. Rather than just being a WWDC demo, how can we use result builders to build a real HTML renderer? And to do that, we're going to start small. In order to be valid HTML, a type must know how to render itself to a string. Because ultimately, everything we produce becomes a HTML string. So we can start with a protocol called HTML that says any conforming type must have a render method that returns a string. And now, if we look at the Swift code from earlier, we can choose a tag to build. Of all of them, this BR is easiest. It just creates the HTML string BR. So our code's easy too. We just send back the correct HTML for a BR struct. And we can use it like this. That's one HTML tag done. Next, let's look at this. They're putting a string right into their HTML. Now, we can't put this inside its own struct because it's just a loose string. So instead, we can make Swift string type itself conform to our HTML protocol, giving it a render method that simply returns the string itself. And now we can call render on a string, like this. And that's pretty pointless, given that we're just printing the string itself. But it's important soon. Back to Apple's code again. The next most complex is this title. This becomes a HTML title element, so it needs to accept a string to show in the page title. So this time, we need a property to store the text to use. And also, a custom initializer, because the synthesized initializer won't match the code shown in Apple's presentation. And now we have a title tag working. By now, you're probably thinking two things. First, this is really easy. And second, how does this use result builders? Well, it doesn't use result builders. But that's about to change, because the next piece of code to implement is this, a H2. This makes a second level heading in HTML. But as you can see, it works differently from the title tag we made earlier. This accepts a trailing closure of content to put inside the heading. So while the title tag only accepts plain text, you can put a range of things inside a H2. Plain text, emphasis, links, and more. This is where result builders come in. Inside the closure being passed to H2 could be any kind of HTML. So we need a way to convert several pieces of HTML into an array we can loop over. But we don't actually need result builders to make such an array. Instead, we can make a H2 struct like this one. This property stores a function that returns an array of HTML, which is exactly what we want. And so we have our render method. We need to call that content property as a function because it'll return the actual HTML to us. We can then loop over each item one by one and call its render method, and then send back the result. So now we have a new H2 struct that can work with any kind of HTML. Remember, this must be given a function that returns an array of HTML types, like you can see here. It's not pleasant, but it is powerful. Because now we can put any collection of HTML inside there and it'll be rendered correctly. Now at this point, I want to take a brief diversion into what could have been. Because result builders weren't the only major change introduced around Swift 5.1. For example, SE 0254 introduced static subscripts. We could try one in our current code. This means adding a static subscript to our H2 struct that accepts 0 or more objects of HTML and returns a string using our existing rendering code. Now, why would we want that? Well, look how it takes the code from this to this. That's much nicer. But those commas are still there. Wouldn't it be nice if we get rid of them too? Well, SE 0257 tried to do exactly that. It proposed that line breaks could be used in place of commas. It even said directly, one case where visual clutter is especially pronounced is in domain-specific languages embedded within Swift, particularly when they are declarative. What does that remind you of? This was before SwiftUI was announced, by the way. And this change would have allowed our code to be written without commas, making this. And if that doesn't seem familiar yet, imagine if rather than using a H2, we used a VStack. Rather than having plain strings, we had a text struct. Rather than a divider, rather than a BR. And the result's almost identical to modern SwiftUI without using result builders. Sadly, this proposal met an extremely negative response on Swift Evolution and was rejected. So we can't use it. This is where result builders are required. First, let's go back to our closure approach. We still want to remove these commas. And we want Swift to convert the content of the closure into an array for us. To make this happen, we'll make a new struct called HTML builder. Now notice this annotation. This will be used as a result builder. So Swift automatically looks for static methods that convert different kinds of content into output. And there are lots of ways this can be called. But for now, we'll use the simplest, build block. We're given a variadic parameter containing 0 or more pieces of HTML, and we'll send back a single array that can be looped over. Internally, Swift converts these variadic parameters into an array for us, which means our output is just our input. And that's our result builder done, at least for now. Let's try it out. Right now, our H2 struct has this content property that stores the array of HTML it contains. To make that use our result builder, we've got to mark the property with HTML builder attribute, like this. And now, when we're writing our code, our square brackets just go away. And those commas, they go away too. So using our H2 struct is much nicer. That one tiny result builder gives us incredibly clean syntax. And now it becomes trivial to go back to the original HTML Apple showed and implement more of it. For example, this body type is almost identical to H2. Here's the complete code for our H2 struct we've made so far. If we change a struct name from H2 to body, and then change the HTML string from H2 to body, it's done. That's now the body tag working. We can use a similar approach to implement the A tag. But if you look at Apple's example HTML, you'll see it has this href method call. This is a modifier like we'd have in SwiftUI. So we can implement it in a similar way. This uses our result builder, just like H2 and body. But this time, we also need a property to store that href attribute, where the link sends users. So to render the link, we render all its contents again, then send back the appropriate HTML. Adding the href modifier means taking a copy of the current object, changing its href property, then sending it back. And now our HTML looks like this. It's much closer to Apple's. We've got a page body, a heading, a line break, and a link. From here, we can carry on implementing the rest of Apple's sample. HTML and a head are all that remain. both of which are just more of the same. But result builders can do so much more. For example, what if we want to generate different kinds of HTML based on a condition, like this? This takes 3 small changes to our result builder. Here's the current code. First, we'll make it no longer work with individual HTML elements, and instead work only with arrays of HTML. And now we have many arrays coming in, we have to flat map our result so that 2-dimensional arrays become 1-dimensional. For our second change, we'll tell our builder that every time it sees a single expression that generates some HTML, it converts it into an array of HTML. And that's enough to get our original behavior back. Swift sees each individual part of our HTML as an expression, then joins each expression into an array. But we want a condition in our builder. We want to generate some HTML only when the showLink Boolean is true. But our builder wants to generate HTML. So what should it do when that condition is false, when there is no HTML to generate? Well, in Swift, we always represent the potential absence of data using optionals. And result builders do the same. We can write a build optional method. It'll be given an optional array of HTML. If the array exists, we send it back. But if it's missing, we'll send back an empty array. We don't want to render anything when there's nothing to render. And now our condition works. When the Boolean's true, extra HTML will be generated, otherwise won't. Let's go further. What if we want one set of HTML when the condition is true and another when it's false? Here's the kind of code we want. It has an if block, like before, but there's also an else. This is easy for result builders. We have to implement 2 methods. Build either first and build either second. Both will be given an array of HTML from one side of a condition. And go to decide what to do with it. Once again, we need nothing special here. We're given a HTML array. We're going to send back a HTML array, so our input is our output. And now we have if-else code working. In fact, that also enables switch case support. Swift compiles all the cases down to a binary tree of if-else checks. Now, all this so far, I think, is interesting, but not really useful. Yes, the compiler checks our code, and that helps avoid mistakes. But think back to the 4 problems I mentioned earlier. Our result builder solves none of those. What we've seen so far is pretty standard. There are several existing Swift projects that build HTML like this, and all suffer from those same problems. And, like I said at the beginning, all those boil down to one huge problem. Most Swift experts aren't also HTML experts. Now, right now, our code might use the same language as Swift UI, but it operates very differently. When you make a tab view in Swift UI, it looks and works in varying ways depending on your platform. On iOS, you get a tab bar along the bottom. On macOS, we get a control group with titles across the top. On tvOS, we get a segmented control. On watchOS, we get a swiping list of views with paging dots along the bottom. And on visionOS, we get a floating ornament on the leading edge. We have not told SwiftUI how to adapt across devices or screen sizes, or how to handle user interaction. That's all done automatically. SwiftUI wants us to take a high-level, declarative approach. We specify what we want to achieve rather than the individual steps required to get there. So, we want a scrolling list of rows, we write this, rather than having to specify all the internals of the list by hand. And what list becomes varies based on the platform where our code runs. SwiftUI automatically moves between UIKit, AppKit, Core Animation, and Metal, ensuring that our UI works great everywhere. And we don't care how complex the code is behind the scenes, because that all gets wrapped up behind a simple list view. Now, if we want the same here, if we want to let users have a huge amount of functionality without needing to know HTML, then we need our own external framework too. And for that, we're going to bring in a popular web framework called Bootstrap. Bootstrap delivers lots of CSS and JavaScript that's considered standard on modern websites, including what's called a reset style sheet. Code that makes websites look the same on all web browsers. And so before we even do any work, just by including Bootstrap in our project, we solve the first of our 4 problems. The second was making sure pages adapt to different screen sizes. And again, Bootstrap solves this. We can place content into rows of data and tell it to render HTML inside there as columns of various sizes. And Bootstrap will adapt its layout based on how much space is available. When the screen's wider, content's placed horizontally. But in a portrait orientation, Bootstrap automatically adapts. Our content gets placed vertically rather than horizontally. So we could build a row component like this. Just like our other components, this uses a result builder, so we can work with any kind of HTML. This time, we'll render the content using Bootstrap's CSS classes, one for each column to be sized for a medium-sized display, and another class for the whole row. And using this new type looks just like our other HTML types, except now we're generating responsive HTML. HTML that automatically adapts to the device it's displaying on. And that's our second problem solved. In just a few minutes, Bootstrap's doing a lot of work for us here. The third problem was trying to bring in more advanced UI elements, like drop-down menus, carousels, and accordions. This goes back to what SwiftUI does well. We say we want a list, a tab view, or another complex view, and it figures out how to make that happen, rather than us having to describe every step required to get there. Again, Bootstrap's got a lot of predefined controls built in, alerts, badges, navigation bars, and more. Let's try one just briefly in a simplified form, a drop-down button showing several options. This starts out similar to the A struct we made earlier. It needs a button title with some items shown inside. As for rendering, this starts out by converting all the items into HTML list items. And then we send back a big string of HTML, because Bootstrap wants things in a very specific form. First, make a wrapper element for the whole dropdown. We then place the button text inside there as a title. Finally, we'll make an unordered list to have the items we want to show. Now, you might look at that and think, that's just back to putting HTML into a big Swift string. But, hold up. What we've done is encapsulate all the HTML inside our drop-down struct. So when it comes to actually using the component, we're just writing pure Swift. Again, this is how Swift UI works, where we don't care what kind of UIKit code is being run behind the scenes, because it's wrapped in neater, simpler code for us. Best of all, Bootstrap supports a standard called Accessible Rich Internet Applications, or just ARIA for short. And what it means is controls like this drop-down button work great with systems such as VoiceOver out of the box. And that's problems 3 and 4 solved. We've got lots of powerful UI components. We're building sites everyone can use. That still leaves us with the one huge problem, helping Swift developers write great HTML. And right now, we're effectively encoding HTML in Swift. They still have to know what all these HTML tags actually do. Now, I've built this result builder following the code shown in Apple's presentation from 2019. But what if we rethought this completely and built something optimized for Swift developers? What if, rather than H2 and A, we can instead write code like this? Text with a foreground style and font, a link with a button style, a divider, and more. That'd be great, right? Swift UI style code that can become HTML. I thought the same thing. So I built a new framework to do exactly that. It's called Ignite. And it's built on Bootstrap to provide an incredible website building experience. It supports all the HTML you need to build websites: text, titles, links, tables, lists, code, and more. It has the full range of Bootstrap controls, carousels, accordions, alerts, and more. It adds important metadata for search engines, social media, and accessibility. And it builds pages that work on all devices straight away. It creates entire static websites from Swift code, including using Markdown for posts. It's built entirely in Swift, with Swift UI style result builders and modifiers. You don't need any HTML. It does not try and convert Swift UI to HTML. Instead, it's a custom set of tools that help Swift developers build fast, beautiful, and accessible websites using a language they already know. Best of all, Ignite's available today, open source for everyone, completely free of charge. Thank you very much.